All right, here is a quick video about how the Coherent Approximation Principle tool works in RStudio. So basically, I've written out some code in RStudio that will accept a probability, coherentize that probability, and produce a graph based on a 3D graph at that based on that information. So I'm just going to quickly walk you through the code step by step and then show you an example of it in action. So the first thing we have here is a section that will search through the packages that are required for this program to work and install them if they're missing, as long as install is set to 1. I don't want to force install things on people's computers that they don't want. So I give them the option of defaulting to no, but the program will not work without these. After this, it loads the required libraries for making the graph, but that's mostly just setup stuff. From here, it goes on to a user input section where they can set some options. So you can set whether you want the output, the graph, the static graph to be printed to your hard drive, whether you want the 3D graph to be printed, and whether you want extended information like errors, such as MAE calculations, to be included in the 3D graph. So if errors is set to 0, it will just produce a generic pop-up window that prompts you to enter any arbitrary number for PA, PB, and PAUB between 0 and 1. But if errors is set to 1, it will actually grab a random question from the Karvetsky dataset and present it to you and ask you to answer those 3 questions. After which it will grab the correct answer for the relevant question, and which it will later plot as well. So in any case, regardless of whether you choose to enter arbitrary values or actually answer a question, it'll create a vector of the elicited probabilities, which in the next section, the program then coherentizes. So it takes vector y and produces the nearest coherentized set of probabilities using the quadprog package, which you can see here. The next section after that will be the actual meat of the program, which is plotting the static and 3D graphs. So there's not much sense in going through all this, but it just basically takes some options such as whether errors were enabled and plots the requested things in the plot space. So let's see. And down here, if 3D plot is turned on, it will produce the 3D interactive plot. So we're just going to go through an example. I'm going to turn errors on so you can see all the information that is potentially presented in this program, and we'll go from there. So what you do here is I'm going to set install to off because I do have all the required packages, but if you did not, you might want to turn this to 1. In any case, you hit Control A to select all the code, and then hit Control Enter to execute the code. So let's go. Okay. Richard Nixon was the 37th president of the United States. I'll be honest, I actually don't know this one for certain, but just to make the graphic a bit more easily readable, we're going to enter kind of a maximally incoherent answer. So we're going to say 0 to both PA and PB, and then 1 to PA union B. So 0 to Richard Nixon is the 37th president. 0 to Richard Nixon is the 38th president. And then 1 to that he is either the 37th or the 38th president. All right. So after it goes through, it will produce this graph right here, which is an interactive 3D plot. So let's walk us through it. The first thing to note is that the x-axis is PA, the y-axis is PB, and then the z-axis is PA union B. So these will print out the labels as necessary. So depending on the viewing angle, it shows some labels and not others, but in any case, so we'll look at it here, PA, PB, and PA union B. This gray polygon that you see here, semi-transparent, defines coherentized probability space. So any points that fall on that line will be coherent. So from here, the orange dot that you see over here is the elicited probabilities. We gave 0, 0, and 1, as you remember. And then the blue is our coherentized probabilities, listed as P, 0.33, 0.33, 0.67. This arrow represents the coherentization process and is labeled with the incoherence metric, IM equals 0.577. And then at either extreme end of our polygon, we have the 3 possible correct answers, as in any general knowledge question will resolve to one of these extremes, the green or the 2 red points. I've highlighted the actual correct answer in green, and the 2 wrong answers are in red. In any case, when it plots, if you have arrows turned on, it will plot not only this arrow representing the transformation from the orange elicited probabilities into the coherentized blue probabilities, it will create an arrow and an associated MAE measure from both the elicited probability measure and our coherentized probability measure, which you can see here labeled as MAE and MAEC. You don't need to produce all of this information. As I mentioned, this is only, normally you would only see the orange dot, the blue dot, and this arrow here, as well as the gray coherentized probability plane. So, all right, in addition to that, there's just one more thing we need to cover, which is just, I'll show you the static graph printed by this function. It looks like this. So this is a bit of a mess because of how much data is stacked on top of one another. But importantly, I will be choosing a figure for the paper that is more easily readable using this angle. You can manipulate the angle of a static figure so that it draws from a different angle that might be more easily readable, but not right now. So I'll make sure that the figure that goes in the paper is probably one that has an elicited probability 111 over here, and it will probably be without all the extra statistics. But for anybody using the interactive program, I think it's a neat Easter egg and helps really solidify the understanding of what's going on with the coherentization process. So that's it for now. I hope that seems interesting to you, and I hope that this will prove to be useful for our submission, if only as supplementary materials. So that's everything for now. Cheers.